Hello and welcome to part 3, final part of your organic chemistry work. This is now where we can actually do the chemistry. Right, what I want you to do is something that we've done in class. In class we have used the molecular model kits to build molecules and rotate them around and therefore get a real hands-on feeling for how the molecules work. But what I would like you to do, that's publishing part 2, don't want that. What I would like you to do is open up a website. It's called Indigo. They make 3D molecules. Indigo 3D molecule. That is what we want. Oh, there we go. We don't want this website. So for me, it was actually the second one. Indigo.com 3D molecular model builder.php. That's what you're after. This website. If you click on it, Indigo Instruments, what they are is they are basically our mods that we use in the lab. They build those, so they can build. So you might have seen some, for instance. Oh, okay. Okay, calm down. Sorry, computer. You might have seen that though you can buy those mods of, say, DNA, and if you're a university, you might have a wonderful set of DNA in the hallway as a big, beautiful display cabinet. And there you go, mod kits. There's our sets, or you can buy them. So we've got the student sets, and we've got the VSEPR mods. But they will build you a huge one and ship it to your company or your university department. And what you can do is you can see what it would look like in advance, and this is what I want you to do. So for instance, ethanol. Build and show. Yeah, well, I don't really care about the purchase options. Oh, look. Oh, sorry. There's my ethanol. And the nice thing is, I can rotate it. So now I asked for ethanol. Therefore, I can, as a teacher, now this is a hybrid dome version. Open sphere. And that's what we build it in our classroom. So here I can see my carbon. There are my 4 sigma bonds, 3 hydrogens, another carbon, 4 sigma bonds, 2 hydrogens, to my oxygen, and the hydrogen. So my hydroxyl, my ethyl, ethanol. You can choose how you want to represent it, whatever you prefer. Personally, I like open sphere. That's the one that looks like what we have in the classroom. So this is how you can use Indigo for making molecules. And what I want you to do is I want you to choose one of the molecules that we have used in class. I do not want anything too simple. Not too simple. So maybe an ester or a halogenoalkane or a carboxylic acid. Nice, complicated molecule. Do not go for the obvious one. If you are doing a halogenoalkane and you just do fluoromethane, you're not choosing the most complicated molecule that we have done. Oh, darn. Sorry. Yeah, this is the problem. You've got to make sure you spell things correctly. Fluoromethane. Thank you. That's better. No, I don't want to buy that. It's not going to be the best. It's too simple. Because what I want you to do is I want you to build a molecule. I want you to tell me about the bonding. I want you to tell me about, if you're doing HR, I want you to tell me about some of the hybridization, the relevant hybridization. I'd like to know HL and SL, the bond angles. I'd like to know about the functional groups. And I'd like to know about any important bonds. So for instance, Here I could talk about polarization, I could talk about delta minuses, delta pluses. If I'm doing HL, I might want to talk about any resonance structures. I want you to choose one molecule that shows me your understanding at an advanced level. Now, if you're doing SL, there is an advanced level. There is a level 7 for SL. If you're doing HL, there is a level 7 for HL. The grading for this will go from 1 to 7. 7 shows, if you get a grade 7 on this assignment, it shows that you have full understanding of your molecule. Level 1 shows you have near zero understanding of this molecule. And in between is an in-between understanding. Choose your molecule, tell me relevant information, save the screenshot of what you're making, upload it to YouTube, send me the link. Once you've done it, I'll feed back. Thank you very much. Good luck.